Hello everyone, welcome to my YouTube channel. Does an electron spin or not? This is what we are going to discuss today. This is a review of the previous video actually. So in the previous video we had seen what exactly is an electron. We had discussed how dynamic general relativity uh, it how it can how its predictions can derive the electron. Literally we can deduce how exactly the electron would look and what exactly are its component parts, whether it's it's a, a basic particle or it is made up of some other particles. So this video is going to be a review of that. There was unfortunately some technical glitch because of which we couldn't finish it. So in that particular video, some questions remained unanswered, and I couldn't finish that video. But that was a good thing because it was becoming too long a video. So now in this, we are going to continue the same video, and we are going to basically ask this question: does an electron spin or not? Or maybe try to answer this question. So whatever I'm going to talk about is basically written in this book, where I have described dynamic general relativity. It's a theory of quantum gravity and a potential theory of everything. So the name of the book is Decoding Gravity, Time, and Causality. Okay. So just quick brush through. We know that classically electron is a subatomic particle. It's negatively charged. It repels electrons. It attracts protons and positrons. And we know that charged particles have lines of forces, and these lines of forces are basically the electrical field. That is, they are the reason why the charged particles attract and like particles attract and repel, and unlike particles attract. So it is also easier to explain this kind of a model of the atom, where there is a central nucleus and surrounding positively charged nucleus and negatively charged electrons, which are attracted towards each other because of the electromagnetic force. But we know that this is wrong basically, because the electrons are not actually spinning around like the planetary model. So this planetary model is wrong according to quantum mechanics. So we know why, because electron is not exactly a typical sphere, but it's a quantum particle. So it has it's a spin half particle. So it has a spin of its own. So it's a miniature magnet, and it has a diameter of 10 to the power minus 18, which is for all practical purposes a point-like particle. So it's an extremely small particle. So it's a quantum particle. It behaves in a very funny way. That is, it honors quantum mechanics. So it is basically both particle and wave at the same time. It has, it can be in superposition of multiple states. It can enter through two slits at the same time. It can get entangled to its other particle. It can, its partner antiparticle. It can spontaneously disappear or spontaneously appear from nowhere in pairs, of course, with its antiparticle. So an electron and positron pair can suddenly appear from nowhere and all. So its future path is basically dependent on something which is described as the wave function. So we don't know what exactly is the wave function, but if we measure the electron, then the wave function collapses, and then we can the electron receive a definite position. So this is all what the electron as we know it till now. So quantum field theory goes one step further. That is, it says that there is an electron field all throughout the universe, and Positive excitation of this field is electron, and negative excitation of this field is positron. So that's what quantum field theory says. So which is, and another thing is what spinor. So not only electron but any charged particle can be a spinor. Spinor is basically a particle where it's a geometric entity in which, when you are spinning the central sphere, if it spins by one, then it will not come to its original position, but it has to spin twice for all these laces to come into its position again. So electron is described as a spinor. So so this is what we know about electrons actually. So then we saw what there are some questions which remain unanswered, like why exactly the electrons repel electrons, or why electron attracts protons. Now the contemporary physics says that this happens because of exchange of photons, and this is typically described with Feynman diagrams, in which they say that the electron one approaches the electron two, and it basically exchanges photon, which is the cause of the. Now we know that need not overanalyze this figure, but we will do that in a minute. So there is another question actually. This is a hydrogen atom. So there is a proton and there is an electron, and then we know that the proton and the electron will attract each other. So they'll keep attracting each other, and the electron will keep falling down, and it will stop falling down at one particular distance from the proton. And why it happens, we don't know. But the quantum mechanics explains this in a manner that this spherical shape of the electron is not exactly the right thing to imagine, because electron is a wave and a particle both at the same time. So electron is associated with a wave. So the wavelength of the wave is such that it is an integer multiple of the. So the circumference of this particular low atomic orbital is basically the integer multiple of the wavelength of the electron wave. So that's how they explain, but exactly how it does, they don't know. But that's what they say, that the reason why the electron doesn't go further down is because this electron wave comes back. Now why does it stop further progression of the electron down? Nobody knows. So why this electron stops moving, we don't know. What is the outward directed force which overcomes the inward directed force of attraction between the proton and the electron? We don't know. So we saw the spaceship thought experiment, and we'll go through it again very quickly. We'll imagine a spaceship basically, which is 10 to the power minus 18. So it's a very small spaceship. It's an electron-sized spaceship. Basically, it's the electron itself, and it's spherical in shape. And Miss X, Miss Alexandria, is sitting in, and she has a photon gun, and her task is what? To send a photon to the other electron. So the other electron is far away. Okay, so she has to basically aim at the other photon, and it has the electron. So we know that the electrons are identical. So there must be some Alexandria or some other person sitting inside that second photon also aiming her photon gun at this particular electron. Now we know that this electron is 10 to the power minus 18, and we also know that this electron is a wave and a particle at the same time. It's in multiple positions at the same time, and it is a way. It's moving at 99% of the speed of light, and it is 10 to the power minus 18, and it's a few meters away, which means that it's an absolutely impossible target for this person. Even if this person is conscious and she has extremely powerful eyes, so we know that there is no conscious person sitting in the electron. So So how does this particular electron, without a conscious person sitting inside, know where exactly is the position of the second electron? So to send the photon. So if there is one single photon which is being exchanged, then how exactly this non-conscious proton, non-conscious electron send its photon? So this is applicable to any charged particle, not only the electron, or the rather even the proton and the electrons will exchange protons. The proton and the electrons will exchange photons. So the obvious answer is what, that Alexandria, she will not aim at any particular particle. She'll just keep pressing the button, and they will keep sending the photon all around. And there will be some Alexandria sitting here, and she will also keep sending photons all around. So here we have shown the photon as a sphere, which is actually wrong because we don't know exactly how the photon looks. So this is another question which we are not exactly aware of. What exactly is a photon? So we know that photon is a packet of energy, but we don't know what is energy itself. So energy is itself an abstract entity. So we know that the photon is having a momentum, and that the momentum of the electron is being transferred from one electron to another electron by the photon. So it has momentum. So it transmits force. It's a force transmitting particle. So it can repel as well as it can attract. So it can have positive momentum. Can it also have negative momentum? And how exactly does a proton have a negative momentum? We don't know. We in fact don't know at all what exactly is momentum. What exactly does it mean when a body has momentum? When a photon, what is photon? We don't know. And if the photon has momentum, whether it's positive or not, we don't know how exactly. So these are all the questions which we need to answer. So another question is, so how many photons per unit time? So if Alexandria is clicking the button, after how much time interval she keeps taking the button, and what time we are supposed to consider, because there are so many times in relativity. There's not a single time. There are multiple times in general and special relativity. So what is a photon? How it looks like? Whether it's spherical, elliptical, oblong, cylindrical, wave-like, particle-like. So we don't know all these things actually. Okay, so we are not very sure of it. So we are going to just try and derive it. So all these things were described in the first video also. So I will just go very fast. Dynamic general relativity says that there will be a corridor. So these two electrons, you can imagine. So if the electrons are there, they will keep repelling each other. So they will keep moving away from each other. So what is happening essentially is that there is active spatial expansion happening in between the two electrons. It may be happening at a corridor as big as this, or it may be a very thin corridor. We don't know. So active spatial expansion is what? Negative energy. So here, if there is a negatively charged particle and a positively charged particle, so they'll attract each other. So what exactly is happening is there will be active spatial contraction in between the two, that is positive energy. So there is a positive energy corridor in between the positive and the negatively charged particles, and there is a negative energy corridor between the two negative energy, that is two electrons. Now we come to DGR. So in DGR we found out that we in the assumptions of the DGR we said that space-time is made up of multiple small Planck compartments, which are basically one Planck volume size, and they cannot be divided further. So energy in dynamic general relativity is basically positive energy and negative energy. So positive energy is what? So there are three types of processes actually: destruction, creation, and entanglement. So if there is excessive destruction happening at one place, it is positive energy. If it is excessive creation happening at one place, then it is negative energy. So the most basic part of negative energy is what? T is equal to zero compartment, and the most basic part of negative energy is called as T is equal to T max compartment. In a T is equal to zero compartment, the time is basically zero. So time is so dilated that it is zero. So if the time, local time, so now in dynamic general relativity there is a local time. So to understand that, you have to see other videos. But local time and general and universal time. So the local time inside the positive energy particle is turned zero. So what exactly happens there? So there is destruction of one Planck compartment in one Planck time. So in one Planck time, one Planck compartment gets destroyed. So what happens is that the surrounding Planck compartment becomes entangled, and they form a EPCA, that is eddy Planck compartment aggregate. So this EPCA or eddy Planck compartment aggregate is like a sphere which is pulled inside. So it will lose its volume and it will have active spatial contraction, and it will try to compensate it. But what exactly happens is what the Planck compartment volume vacuum, that is PC vacuum, which is created because of the destruction, will be shifted outwards, and then again it will be shifted outwards, and again it will be shifted outwards, like that. So the first sphere will move inwards, then the second sphere will get entangled, then the second sphere will move inwards, and third sphere will get entangled. So in that manner, you can number these spheres. This positive energy particle, what is happening here in this T is equal to zero compartment is that in a single second, 10 to the power 43 Planck compartments are being destroyed. And T is equal to T max compartment. Again, the same thing is happening in the reverse way. That is, there are 10 to the power 43 extra Planck compartments being created from nowhere. So these are the positive energy particles. Now, what happens in the negative energy particle? So in positive energy particle, these EPCAs are basically positive energy because they are having active destruction within them. But there is a slight time dilation, but it's not as much as the center. So the time dilation keeps reducing as we move outwards. So if two positive energy particles come close, what will happen is the time dilation because of this and time dilation because of this will add up. So what happens is that the zone in between them will have excessive time dilation. So it will keep contracting more and more, and then they will coalesce. So positive energy particles can coalesce. But what about negative energy particles? Negative energy particles will have a not time dilation but time contraction all around. So in the center there is a very high amount of time contraction, the maximum time contraction possible, and periphery there will be basically as we move forward outwards, the first sphere, the second sphere, the third sphere will have much less time contraction, but it will be time contraction. That is, active spatial expansion will happen in that. So active spatial expansion, if the two positive and negative energy particles come close to each other, the time contraction will get added up in between the two. So they will keep repelling each other. So it's essentially what's happening is the negative energy particles will not form aggregates and they will keep repelling each other. They cannot come together. And in this manner, they will form eddy Planck compartment aggregates, and the vacuum which is created or the void which is created in between, it keeps moving outward. It keeps moving outwards, and it keeps getting compensated. In this manner, it will create a positive energy particle will create a positive energy EPCAs, or which are actually time resetting waves. So these are time resetting waves which will reset the time peripherally. These are time resetting waves which move extremely rapidly, much faster than the speed of light outwards. Because here these are Planck compartments, so these are actually space, and that's why the Einsteinian limit doesn't apply to this. So this is again another interesting this thing. So the Earth, in the center of each of the particles of the Earth, what is happening is an extreme amount of destruction is happening because of the mass of the Earth. So what is happening is just outside the surface of the Earth, there will be EPCL formation. So EPCS, there will these are the time zones which are because of time dilation of the Earth. So all these there will be a active spatial contraction. So these EPCs will keep moving downwards. So this will go down, this will go down, this will go down like that. And this is another particle, positive energy particle, which is there in the center. So because of the mass of this particle, it will also form EPCs all around, and these spherical EPCs will also keep moving inwards. So this will move inwards, this will move inwards, this will move inwards like that. So this will basically form its own time dilation. So the time dilation over here and the time dilation over here will add up. So there will be excessive time dilation over here, which means that this particle will keep moving inwards because there will be active spatial contraction over here. That's how gravity is described. But this is not relevant to this talk basically. So this is more relevant actually. So this shows P and Q, which are actually positive energy particles. So they have a hypothetical time dilation. Now, what exactly is hypothetical and time dilation, I won't be able to tell. But basically, it's not the real time dilation. So this has some destruction. So this has some time dilation, but this time dilation will not go linear outwards. So this will also have some time dilation, but much less than the center. This will have much less than this. This will have much less than this. This will have much less than this. So we are just giving random numbers to linear numbers so to understand. So if this is 7, then this will be 6, then this will be 5, this will be 4, like that. Here, if this is 7, 6, 5, 4, 3, 2, 1. So you can understand that this will cause one time dilation in this zone, but this will cause 6 time dilation in this zone. So the time dilation will add up. 1 plus 6 will be 7. So here in this particular region, there will be addition of the time dilation because of this as well as this, which means that in this particular area there will be excessive time dilation. So all these will be 7. So there will be active contraction in between the two. That means that they will attract each other. So that's how positive energy particles will attract. As far as negative energy particles are concerned, the same thing is applicable. Just this 7 will become -7. So this is not time dilation but time contraction. So if this is -7, -6, -5, -4, like that, -7, -6, -7. So all these will also become -7, -7, -7, which means that there will be time contraction, extreme time contraction in between the two. So they will keep pushing each other rather than pulling each other. So they will not form aggregates. So this is what negative energy particles. So negative energy particles will never form aggregates. So what happens if there is positive energy and negative energy particles both together? So P is a positive energy particle, Q is negative energy particle. P, there is a lot of destruction happening. Q, there is a lot of creation happening. So around the P, there will be time dilation, and around Q, there will be time contraction. So what happens is the surrounding the just in between the P, the P will keep pushing, the P will keep pulling Q towards each other, towards itself, and Q will keep pushing the P away. So this is exactly in line with what Bondi suggested. Just that Hermann Bondi said that for positive mass particles and negative mass particles, which is actually similar to positive energy and negative energy particles. But that's what DJR has come into. Basically, DJR has predicted the same thing, that the positive energy particles will come closer and closer to each other and they will form aggregates. The negative energy particles will keep repelling each other. The positive energy and the negative energy particles will basically enter into something called as a perpetual motion, which was not liked by a lot of scientists. But this is what even dynamic general relativity is saying, that the negative energy particle and positive energy particle will form a pair. So if they form pair and they get bonded, when the negative energy particle will keep running away from the positive energy particle, and the positive energy particle will keep attracting the negative energy particles, so it will keep following it. So what happens if multiple such pairs are coming into contact with each other? What will happen is these negative energy particles will keep pushing each other, everything. So even this will push this also, this will push this also, like that. But these positive will attract. So the positive and positive will attract, positive will attract. Like that, ultimately what will happen is all the positives will attract each other and negatives will form a small lattice. They will stay away from each other, but they will stay bonded, but they will stay away from each other, and they will stay away from the center also. Like that, what essentially is happening is that there is a the central positive energy particles will coalesce into a much bigger positive energy core, and the negative energy particles will stay around as positive energy lattice. So that is what is the ultimate description of electron in dynamic general relativity. It is called as the matter-antimatter model of the electron. Here, what is happening is that there will be matter particle or positive energy particle core in the center, which is equivalent to the mass of the electron, and there will be a anti-particle, that is negative energy particle, or ENEA particle. What is called as ENEA particle is what? Exotic negative energy antiparticle, ENEAs. So these are ENEAs. So this is basically a ENEA lattice, which is each of these will have excessive time contraction. That is, there will be T is equal to 0, T is equal to T max compartments or negative energy particles. So they will have excessive creation in them, and here there will be excessive destruction. So if there are 1 million ENEA particles, there will be equivalent number of T is equal to 0 compartments here. So 1 million destruction is happening here, and 1 million creation is also happening here, but it's in the form of a lattice. So what is happening here is that there is a lot of destruction happening. So there will be a lot of PCA formation. All these spheres will form all around, and these spheres will keep pulling the surrounding space inside. So there will be a sphere which will be formed over here. There will be a void which will be formed over here. So all this will have active spatial contraction, and all these spheres will move inwards. So there is one particular sphere which here it will be. It will be pulled inside, and there will be formation of a Planck vacuum all around, PC vacuum. So this PC vacuum has to be compensated somehow, but it cannot be compensated by the negative energy particles. So it has to be compensated from the gaps in between the ENEA particles. So essentially, at the same time, the excessive amount of creation which is happening at here cannot go here, or cannot go here, or cannot go here. So it has to go there. So that's why the zone which is there, where there is no any particle, so the gap zone, or the zone A, will have excessive amount of positive energy, that is active spatial contraction. From here, the Planck compartments will be pulled inside, and they will be used for compensation. Here, Planck compartments which are getting excessively created will be pushed in this zone B, and the zone C will be the zone where there is no energy, or there is balance creation and destruction. So zone A will be excessive destruction, zone B will be excessive creation. So basically zone A is positive energy zone, and zone B is negative energy zone. So basically the electron will have multiple zones around them, or bands or corridors around them. The zone, so these bands can be called as push bands and pull bands. The push bands are the negative energy bands, and the pull bands are the positive energy bands. So every charged particle, rather, not only electron, will have both push bands and pull bands all around it. So the emerging description is somewhat similar to the spinor, where there is a central positive energy core, and there is a lattice of negative energy particles which are spinning Now this lattice cannot remain stable because it has extreme amount of creation which is happening. So this will basically push the lattice to spin around. So if it spins around, then the push and pull bands will emerge from it, and they will keep spiraling around. So this is what the electron, which is described by, or which is predicted by dynamic general relativity, looks like. Some of them will be pull bands and some of them will be push bands. So this is how a push band or a pull band will keep moving. So as soon as it forms, it will keep moving outwards in the same direction, but the ENA lattice will keep rotating like that. So the starting point of the push and pull band will keep rotating down around like that. So that is how the spiraling of the push and pull bands can be explained. But this is a very weird thing actually. So how do we describe what is a negatively charged particle, what is a positively charged particle, what is a neutral particle? So we have to explain all these things as well. So how we can explain it like that? So let the number of positive energy particles, so T is equal to 0 compartments, be X. So if that is the case, then if the number of negative energy particles, that is ENES, that is exotic negative energy antiparticles, which is the negative energy version of the positive energy particles, which is the T max, T is equal to T max compartments. So if in this particular composite particle, if the ENA particles are also exactly the same as the positive energy particles, then it will be a neutral particle. But if the ENA particles are more, then it will be a negatively charged particle, and ENA are less, then it will be a positively charged particle. So needless to say that we don't know exactly how it will be, but this is what is our assumption or guess. So further research will be needed before we know that this is right or wrong. But this is what we feel, that negatively charged particle will have ENA excess or negative energy more, so they will have more repulsion tendency, and positively charged particle will have more of positive core, so there will be slight deviation towards positivity and slight deviation towards negativity. So what about symmetry? Is the electron symmetrical or asymmetrical? So we know that there are left-handed electrons and there are right-handed electrons. So if the ENA lattice is spinning, is the ENA lattice symmetrical or not? For understanding that, we have to look at this example, or basically thought experiment. So let this be Alexander and this be Alexandria. So the electron is spinning in this particular direction. So for this Alexander, up is this and down is this. But for Alexandria, up is this and down is this. So so if this Alexander points towards his up, points the thumb towards his up, then this will become a right-handed particle. But the same, the other person, that is Alexandria, she can point the thumb down. So she is, because the down is the up for her. So she will point. She can point the thumb up, and even then this basically this particle will become a left-handed particle. So if the electron is a symmetrical particle, then it cannot be called as a left-handed or a right-handed particle. So for it to be called left-handed or right-handed particle, we have to basically know which pole the thumb goes to. If the thumb goes to one particular pole, and both of them know that, then they whatever is the orientation of the scientist, they will not make a mistake. So essentially what is happening is that a negatively charged particle or a positively charged particle will have either a ENA axis or a positive energy axis. So this particular ENA lattice will basically be slightly asymmetrical with one pole which is a ENA deficient pole and the other pole will be ENA excess pole. And you can see that the ENA deficient pole will have active spatial contraction. So this will pull this and this towards each other, and there will be any excess pole where there will be excessive expansion tendency. So they will repel each other all over here. They'll here the ENAs will be crowded, so they will repel each other. So they will move in this direction until this becomes a ENA excess pole. So what happens is that this ENA excess pole switches to here and the ENA deficient, this becomes the ENA deficient pole. So like that there will be a pendulum like movement of the ENA particles in the lattice, and that causes a switching of the, this can very nicely explain superposition of the spin of the particle. So the spin will keep changing. From this electron will change from left-handed particle to right-handed particle. How? I will tell you. So this is how it is, you know. So this is a ENA deficient pole of this electron, and this is the ENA excess pole of this electron. The lattice is spinning in this direction basically. So if we say that you know, we make a rule that the thumb has to be pointed towards the ENA deficient pole. So the ENA deficient pole is here up. So this will be a right-handed particle, right? So because I'm using the right hand. So now as soon as this is ENA deficient pole, so there will be more positive energy here. So there will be more destruction here. So the ENAs will get pulled towards this pole. So soon what happens is that ENA excess, this will become ENA excess pole and this will become ENA deficient pole. So now the direction of the lattice is same, but now the this thing has changed. The handedness has changed because ENA deficient pole is now down. So thumb has to be pointed down. So now this becomes a left-handed particle rather than a right-handed particle. So here this was a right-handed particle, but here this is a left-handed particle. So the direction is same, but poles have shifted. So if the poles have shifted, this becomes a so here you can understand that this will keep shifting. ENA deficient pole will go from here, then again here, then again here, then again here, then again here. That's how superposition of spin of an electron can be explained very nicely. So Stern-Gerlach experiment and its findings can be explained very nicely with this. So that you know, when we pass the electron through a spin to a magnetic field, this particular thing can get stabilized and it will remain as a right-handed or a left-handed depending on what is the direction of the. And then again, if you make the direction perpendicular, then again the spin will get. Another thing is what that around the charged particle there are cones basically. So for the push band, all the push bands will remain in a particular cone, and all the pull bands will remain in a particular cone, because all the pull bands are basically emerging from the gaps, and all the push bands are emerging through the ENA particles. So the ENA particles, wherever they are there, that from there they will be basically at a different level, and the push bands, pull bands will be in this particular level, and pull bands will be in this particular level. So they will be in a different cone. Now this is basically how you can, for better understanding of what the electron is as predicted by dynamic general relativity, you can describe a small model. You can imagine that there is a hollow metallic sphere, which has multiple holes in it. It's like a fenestrated. So multiple holes are there all around. So here only 4 holes are shown, but all around there will be holes. And this sphere you can submerge in water. And at the center of the sphere, there is a pipe and there is a suction apparatus attached to this. So here there is something like a hole. So the water will be pulled inside and it will go out. So there will be a void created. So the surrounding fluid will take its place, and then surrounding fluid will take its place, and surrounding fluid will take its place. Like that, the fluid will keep moving in this direction from all around. Okay. So there will be a time which will come where there is a void created over here. So the fluid will have to be pulled out from here for compensation. Now, in between the two fenestra, there will be zones here which will be connected to two tubes under pressure. So there will be water being pumped here, so that there will be a stream of water which will come through this. Stream of water will come through this. Stream of water will come through this. So water will be pulled from here, and the water will be pushed from here. So in a way, because of this push of the water, this whole apparatus will start rotating, and there will be zones of excessive pull and excessive push, and there will be zones in between the two where there will be no excessive pull or push. So you can see that if there are 20 such push areas, so then this has to be much more, that is equivalent to 20 or 21 or 22, like that. If this is equivalent to 22, then it's a positive energy particle. If this is equivalent to 19 or 18, which is less than the ENA particle, then it is a negative energy particle. So in that manner, you can actually understand with the help of a model how exactly the electron is predicted by dynamic general relativity. Now, although I have tried to explain how the electron is, and there are a lot of questions which still remain. So if you want, which I couldn't describe in this particular video, but they are there in the book. So I think you should check out the book, Decoding Gravity, Time and Causality. And I thank you for your patience, and I would recommend that you subscribe and you share this video with everyone, so that people will know. Thank you very much for your attention. Have a nice day.